Hi, my name is Kajan Singh, and I'm a student in Frisco, Texas, and this is my presentation. So the name of my presentation is Monitoring a Plant Using PubSub Plus, Raspberry Pi, and Flutter. So a little bit about me. I'm an 8th grader from middle school student from Frisco, Texas. I like tech and computers, and I love nature, which you'll see it come into play later on in the presentation. I do running as a sport. I like pizza, and my favorite hockey team is the Montreal Canadiens. So that's a little bit about me. Now onto the actual presentation. This project is all about collecting data from sensors and pushing it to a mobile app in real time using a database and Solace PubSub Plus. So I'm talking about the project, but what is the project? So it's a Raspberry Pi based project, so here's a little bit of a summary. So I've had this plan that I've been sort of neglecting for a little bit of a while now, and I want to take care of it, but I really haven't had the time to. So what I've done is I've made a project using a Raspberry Pi and sensors, which will monitor the plant. So the sensors are going to collect the data about the plant, and they will use that sensor data to perform an action depending on the results received. So it could basically send a notification to my phone about the data in the plant that if I need water or not, or if the area condition is suitable for my plant. And in this case, it's an apple tree. So if for that specific apple tree, if the temperature is right or the humidity in the air is wrong, or if it needs more water. So on how it works, it has a Raspberry Pi as the main processing unit for the whole project. It has sensors, a Firebase Server, mobile app, and Solace PubSub Plus. So a little bit about this flow diagram and how it actually works as a project in all. So the sensors are going to be reading data from a plant and basically collecting information about it, like humidity, temperature, and moisture in the soil to determine if it's good for the plant, the area, and the water level in the soil. And the Raspberry Pi is the main brains of the operation. So what the Raspberry Pi would do is it would take in the data coming in from the sensors, and it would basically process that data to actually make a use out of it. So in my case, I'm making the Raspberry Pi send data to a Firebase real-time database. So after it sends the data there, it would real-time update to a Flutter app that I created. So basically you can view data on your phone, such as the humidity and temperature of the plant itself. So wherever you are in the world, you can check up on your plant and see what's happening. And I came into a little bit of a problem in making the app. So the Raspberry Pi won't be refreshing the data every couple seconds, because then it might overload the server. So what I made it do is that it would only refresh the app data and ask the Raspberry Pi to resend it whenever it's actually necessary, like when you open the app. So to create that system, I made the app have a button, or whenever you open the app, to actually send a refresh signal to Solace PubSub Plus, which acts as a sort of a broker in the middle, which would then be able to have the Raspberry Pi listening to it, which would then make it so that the Raspberry Pi would get that notification from the topic that it's received from, and then go through the whole loop again, so you can see real-time information coming in from the app. So now about every small parts of it, for the 5 main parts of it, sorry. So the Raspberry Pi is the main computer. It's an affordable but yet powerful mini computer, and it is what processes and reads the data coming in from the sensors and uploads that into the server in which the app can read from. So as I've explained before, it's the main brains of the operation, and it's what actually, I could say, controls the whole thing and decides what to do with the sensor data coming in from the plant. Next up, we have the sensors. So I've used two main key sensors in my project, the DHT11 sensor and a soil moisture sensor. DHT11, it has two main characteristics to it, and that it can read humidity and temperature. So the reason I chose humidity and temperature is that the DHT11 humidity would read the amount of water vapor in the air to determine if it's dry or not and if it's sort of a suitable condition for my plant. And the DHT11 temperature sensor would determine if it's a suitable condition and if it's like either too hot or cold for the plant to actually handle that area. Lastly, I have my soil moisture sensor, which would check if the plant has too much or too little water. So if it has too much, it would tell you, oh, don't put any more. And if it needs water, it would ping you on the app and ask you to, oh, well, you need water. So that's what the sensors are all about. Next, I made a Flutter Mobile App. So to view the data coming in from the plant, you need some kind of medium to view it from. That's where Flutter comes in. Flutter is an open source UI development kit created by Google that allows you to build cross-platform apps. And the reason I chose Flutter as my app building platform is that it's quite easy to use once you learn it. And it's really powerful and has a lot of interconnectivity between certain libraries like MQTT to talk with Solace, and it works really well with the Firebase real-time database. And as you can see on the bottom right, it has the humidity shown on the screen and the temperature so that you can check it in real time, and a refresh button to refresh the whole data. So as I was talking, the Firebase server. Firebase is what will store the data read from the Raspberry Pi and what the app will read from. Firebase is a backend which allows for multiple functions such as a real-time database and other analytical and many other things actually. But the main reason I chose that as my database is it works really well with Flutter because it's also made by Google, which makes it convenient to use. And they're kind of just built into each other, which makes Flutter and Firebase a really good combination. Lastly, I use Solace PubSub Plus to refresh the data in the app. I had to have a way so that the app can talk directly to the Raspberry Pi to ask it to resend new data. To do that, I use Solace's MQTT function to directly communicate from the app to the Pi. So as I've explained before, the app will send a refresh signal on a topic such as plant / a username / refresh, which will then be sent to the broker, the Solace PubSub Plus broker that I set up in the cloud. And then the Raspberry Pi, it would be listening to that. And whenever that signal is received for that certain topic, it will then go through the whole process of reading from the sensor, sending to the server, and then you can view it on your app again and view statistics for the app. So why did I make this project and why am I telling you all of this? So how event-driven sensors can help improve our lives in just every day. So what I'm doing in my project that I've built is precision agriculture, which is using sensors to improve farming efficiency. So according to the World Bank, about 70% of the fresh water used globally is used in agriculture. Of that 70%, 60% is wasted due to poor water management, according to earth.org. So if you do the math, about 42% of the Earth's water is used in agriculture and wasted, which using sensors, it can help. So the sensors will help with detecting when they need water or nutrients to produce the most efficient amount of result. So the plant can basically grow to its full potential without any waste. So that's why I made this project and what is the purpose of it. So think of this scenario. You have a plant in a farm, which farmers, they build their farms on many acres of land. So you would have multiple sections of plants, and for each section of plants, you would have a moisture sensor to detect if water is needed. So for each area, so let's say there's 100 areas for each plant where the moisture sensor will be located. It would basically individually track all of them to see if there's enough water in all of them and if it needs replenishing. If it needs replenishing, it would send a water notification to a processing unit. So for my use case, I used a Raspberry Pi, but for larger, bigger scale operations, you may want a more powerful computer because, again, there will be hundreds of connections coming in. But for that one area, if it needs water and it sent a water notification from the sensor, it would then send an alert to actually water the plant. So it could be sent to a human, but you can also have an automated watering system that could automatically water it and know exactly how much water you should put into the plant. So basically that would make a really efficient way of watering the plant back, and the whole cycle would go again and again. And basically the whole farm would be automated on its full potential because water won't be wasted, and because you know exactly when to water and not to water when it's too much or too little, and basically not making the plant grow to its full potential. So basically by doing this, it would go through automating the whole cycle without any human intervention, which would make it extremely efficient for building a farm. So here are my sources, and thank you for listening to my presentation about my project that I made. And I'll end it off with a quote: "Take care of the earth and she will take care of you." So respect the earth and she will do her part back to you. Thank you.